We have reached a point in the observation of 3IATLAS where the most honest thing a scientist can say is, I don't know. Just when we think we have a handle on this object, just when the data starts to form a coherent picture and the orbital models stabilize, a new batch of observations comes in and throws the entire board sideways. It is like trying to nail down smoke. You think you have it contained, you think you understand its vector, and then it drifts somewhere else entirely. If you have been following this saga, you know this isn't normal. This isn't a predictable comet behaving the way dirty snowballs from the Oort cloud are supposed to behave. This object keeps changing, shifting, and rewriting its own physics as it moves through our solar system. And what changed today might be the strongest indication yet that we are watching something truly unprecedented unfold in real time. NASA has just issued another alert, and I need to break down exactly what is happening because this isn't just about a brightness flare or a pretty new tail structure. This time, the shift showed up in the math of the orbit itself. Overnight, tracking stations around the world fed a fresh batch of high-precision position measurements into the global database. These are the same telescopes, looking at the same object, using the same data reduction methods they always use. Nothing changed in how we are observing it. But when those new numbers were plugged into the orbital calculation software, the residuals started acting weird. In orbital mechanics, residuals are the tiny differences between where the math says an object should be and where we actually see it in the sky. In a perfect world, residuals are zero. In the real world, they are small and random, scattered like noise. But today, the residuals for 3IATLAS didn't scatter. They lined up. They formed a pattern pointing in a new direction. This is significant because it means the motion of the object has fundamentally changed. A normal asteroid moves by gravity alone. The Sun pulls it, Jupiter pulls it, and we know exactly where it goes. But 3IATLAS is active. It is venting gas. And when gas shoots off in one direction, Newton's third law kicks in. The object gets pushed in the opposite direction. It's a non-gravitational force, essentially a tiny rocket engine that is always firing, nudging the comet off its pure gravity path. Up until yesterday, we had that push characterized. We knew the direction, we knew the strength, and the models accounted for it. But today, to make the new observations fit, that push has to be tilted. The thrust vector from the comet's jets has rotated. It hasn't spun wildly, but it has shifted enough that the software can't ignore it. The math simply doesn't work unless we assume the engine natural or otherwise is pointing somewhere new. While the orbital dynamics team was scratching their heads over the numbers, the imaging team finished processing a completely separate set of observations. They stacked multiple exposures to create high contrast images of the inner core. And because the universe loves consistency, the pictures tell exactly the same story as the math. In images from last week, the main jet looks stable. Today, the inner coma, that bright fuzzy region around the nucleus, is skewed. The brightest part of the glow has moved. The main stream of material is leaning in a new direction, and the secondary fans of debris have rebalanced themselves. Even the tail has picked up a subtle S-curve that wasn't there before, like the whole structure twisted in the wind. So we have two independent lines of evidence pointing to the same conclusion. The orbit says the force has rotated, and the pictures say the jets have rotated. That is not a data error. That is a physical change happening on a massive object in real time. The obvious question is why? What is going on inside 3IATLAS that keeps making it change its mind? To understand this, we have to look at what a comet nucleus actually is. It's not a solid rock, it's a fragile pile of frozen rubble, a mix of water ice, carbon monoxide, and dust held together by weak gravity and hope. When it gets close to the sun, the heat soaks in. It doesn't heat evenly though. The sun only hits one side at a time. As the temperature rises, volatile ices deep inside turn directly from solid to gas, building up pressure until something cracks. A vent opens and you get a jet. For months, it looked like one main vent was doing all the work, providing a steady push. But as the comet cooks in the solar glare, the deep interior is still reacting. One possibility is that a new vent just blew open. Maybe a pocket of volatile ice buried under a thin crust finally reached its breaking point, bursting through the surface and creating a new jet firing from a completely different location. If that new jet is strong enough, it could overpower the original one, shifting the net thrust and changing the orbit. That is the straightforward explanation. But there is another possibility that is even more interesting. The object itself might be wobbling. Jets apply torque. Imagine a spinning ice skater. If they move their arms, their spin changes. A comet is similar, but instead of arms, it has jets firing at weird angles. Every time a jet fires, it applies a tiny twisting force. Over thousands of rotations, those tiny torques add up. We already know 3IATLAS isn't spinning smoothly, it is likely tumbling. If the spin axis is processing wobbling like a dying top, then the direction the vents are pointing changes over time, even if the vents themselves never move. Today's shift might just be the next step in a slow, chaotic wobble. Both explanations fit the data, but here is where it gets worrying. Every time the thrust direction changes, every time a new jet comes online or the spin axis tilts, you are redistributing the stress inside the object. Remember, this is a fragile pile of rubble. When a jet fires, it pulls material off the surface, changing the mass distribution. Parts of the comet that were in shadow suddenly get blasted by sunlight. Cracks that were stable get pulled in new directions. In the short term, this just looks like a trajectory shift. But over months, these repeated stress tests add up. We have seen this story before with comets in our own solar system. They go through this exact pattern, shifting jets, changing spins, and then, without warning, they disintegrate. The nucleus simply can't take it anymore, and the whole thing comes apart in a cloud of dust. Now, the official alerts are very careful. They use technical language like evolution in outgassing direction, an update to orbital solution. They don't say imminent breakup. But actions speak louder than words. You don't schedule extra telescope time, you don't push observatories to collect denser data, and you don't send out internal alerts unless you know something interesting and potentially catastrophic is happening. You do it because the object is active in a way that matters. The bottom line is that 3IATLAS is not just coasting peacefully out of the solar system. It is fighting its way out. It is still burning, still venting, still actively adjusting its motion layer by layer, vent by vent. Yesterday's shift wasn't the final word. Today it shifted again. We are essentially watching a live experiment. How does an alien object formed around a different star billions of years ago respond to our sun? We don't know how dense it is. We don't know how strong it is. We are learning all of that by watching it struggle. It might stabilize. In a few weeks, the activity could settle down and the comet could limp away intact. Or it could keep shifting. The stress could keep building until one final wobble redistributes the load just a little too much and something fundamental gives way. We don't know yet. That is what makes this so fascinating and so frustrating. This alert is just another data point in an ongoing mystery. Will the next alert say it calmed down, or will it say it shifted even more dramatically? Observatories around the world are keeping their eyes locked on this target. Every clear night, someone is collecting data. The orbit keeps getting refined, the images keep getting sharper, and the models keep changing. This is what makes observing 3IATLAS so compelling. It isn't static, it isn't dead. It is a dynamic, evolving visitor that refuses to be predicted. And when that visitor is the only sample we have of what lies out there in the wider galaxy, every little twitch, every small shift in the math becomes incredibly important. 3IATLAS shifted again. The engine rotated. And whatever happens next, whether it's a breakup or a breakout, we will be watching.